Dividing polynomials. We're going to be working with dividing polynomials. We're going to start with dividing a polynomial by a monomial. And we're going to be using the quotient rule of exponents. And remember, the quotient rule of exponents is it's division, and you have to subtract the exponent and leave it where the higher exponent is. So we're going to do an example here. We have a polynomial, 10x to the third minus 5x squared plus 20x, all being divided by 5x. First, separate it out into 3 separate division problems so that you're dividing that 5x into everything the polynomial is. So you take each piece and simplify. So I'm going to simplify the first piece. I have 10 divided by 5 is going to give me 2, and x to the third divided by x is going to give me x squared. Remember, you're subtracting, and the x has an exponent of 1, so you have 3 minus 1, and that's the x squared. The next piece, my 5's are going to cancel out, so I'm going to just simply be left with x. And remember, don't write a coefficient of 1, and don't put an exponent of 1. So we just simply write x in this case. And then lastly, you're going to reduce. 5 goes into 20 4 times, and my x's will cancel out. So this would be my answer. Notice this next example. Again, I'm doing a polynomial divided by a monomial. I'm going to separate it into 3 separate problems, and I'm going to simplify piece by piece. So my first piece, I see that the 5's are going to cancel. X to the third's on top over x squared, so I'm going to simplify by subtracting the exponents, and the highest exponent's on top, so it simplifies to just x. Remember, no coefficient of 1, just leave it as x. Now when you look at the next piece, 9 over 5 does not simplify, so I'm going to end up with a 9 over 5, and the x squared over x squared simplifies, so it cancels out. So I just get a negative 9 over 5. And then this last piece, notice my highest exponent for the variable is in the denominator, so when I subtract, it's going to stay in the bottom. 5 divides into 10 2 times, and I'm going to be left with 2 over x. So be careful when you're doing the division of a polynomial by a monomial that you use the quotient rule, and wherever the higher exponent is where it's going to end up in your answer. Pause and try. I like to separate it into 3 separate problems, reduce piece by piece, and you should have gotten your answer is 3x squared minus 2x plus 5. Pause and try. I'm separating it into 3 separate problems. When I simplify the first piece, notice I have 4x to the fourth over a negative 4x to the fourth. That's going to give me a negative 1. And because I have a negative, that's going to change that to a plus, and I'm reducing that 6 over 4 is going to be 3 halves, and my highest exponent is in the denominator, so I'm going to subtract and leave it in the denominator. So I end up with 3 over 2x. And then the last piece, all I have to do is deal with that plus minus. That plus minus is going to change to a minus 7 over 4x to the fourth. So now, before we get into long division of polynomials, I want to do a quick review of long division of arithmetic. So again, long division, you set it up as the long division where the divisor goes outside and what you're dividing into goes inside. And when you do the division, you're only looking at a piece of the number you're dividing into. And it's the first piece, and you want to think, how many times will 5 go into 7? Whatever that number is, you're going to take it and write it above, and then you're going to multiply it to the 5. So you do 1 times 5 will be 5, and then you write it underneath the number. The next step is subtraction. You have to subtract. You never see the subtraction sign, but you know you're subtracting, and whatever you get left, you're going to put underneath. So we did 7 minus 5 is 2, and then the next step is to bring down the next number. Just the next number. And then you're going to do the whole process over again. How many times will 5 go into 21? 4 times. You get 4 times 5 is 20. You do the subtraction, and again, you won't see the subtraction sign, but you know you're subtracting. And then you're going to bring down the next piece, and you're going to multiply 5 by 3, and you're going to get 15, and you subtract, and you get your remainder is 0. So this is just a quick review of what long division looks like with arithmetic, but long division with polynomials is similar to this. So before we start dividing polynomials, it is important to check the following conditions before dividing. The first condition is the polynomial must be in standard form with the exponents in descending order. And what that means is you need to have the term with the highest exponent in the first position, and then it goes in descending order all the way down to the constant. Next, you want to check if there's any missing terms. A missing term is if you have an x to the third, then that means that you need to have an x squared, you need to have an x, and you need to have a constant. If you don't have all the descending terms from the highest exponent, you will need to put place markers in with a coefficient of 0. You can either leave a gap, or you could put the place marker. If there's an x squared missing, you would put 0x squared. And we're going to see examples as we go through this lesson. So we're going to do long division of polynomials. I have this trinomial 2x squared minus x minus 10, and it's being divided by x plus 2, that binomial. So the first thing I like to do is I like to set it up. The x plus 2 on the outside with the 2x squared minus x minus 10 inside. Now, similar to the long division in arithmetic, I'm only focused on the first piece here. So I want to get rid of the 2x squared. So I'm looking at 2x squared and this x, just the x, and thinking, what can I multiply x by to get the 2x squared? What do I multiply x to get 2x squared? Well, 2x will give me a 2x squared, but what I multiply x by, I need to make sure I multiply the entire thing by that 2x. So you can't just multiply the x and put it underneath the 2x squared. You have to multiply the entire thing. So you're doing the distributive property here. So you have 2x times x is going to give you that 2x squared, and that's what you wanted. And then you have 2x times 2, which will give you plus 2x. So now you did the multiplication part, and the next step is to subtract. So the next step in long division after you multiply is to subtract. When you subtract, though, and we have a expression, you have to be really careful, because really what you're doing is distributing a -1 to the entire expression. So you're changing the signs of everything. So you end up getting a -2x squared, and that plus 4x changes to a -4x. So when you're doing long division of polynomials, don't forget this step. Because we're subtracting, you have to change the signs of everything. And then the first piece is going to cancel out, 2x squared minus 2x, and then the next piece you'll simply do the combined like term here. You have a negative x, which is really a -1, minus 4 will give you a -5x. So you do the subtraction here, you get a -5x, and then the next thing is to bring down the next piece. So the next thing you're doing now is repeating. You're only focused on that -5x and the x. And you need to multiply that x by whatever is going to get you that -5x. So if I multiply by a -5, I'll get a -5x. So you have to make sure you take that -5 and distribute it to the whole thing, the 2x. So you're going to multiply the negative 5 to the 2x, which uses the distributive property, and you're going to end up with a negative 5x minus 10. You need to subtract, so you're going to end up distributing a negative or changing the signs of everything, and then you add down and you end up with 0 as your remainder. So in this case, your solution is going to be that 2x minus 5. Pause and try. So you set it up. You have 2x plus 1 being divided into 2x to the third minus 9x squared plus 7x plus 6. Now you're only focused on that 2x to the third, and you want to know what to multiply 2x by to get 2x to the third. So you need to multiply by x squared. You're taking x squared and you're distributing it all the way through to the 2x plus 1. And then you end up with 2x to the third plus x squared. The next step is to change the signs or distribute that negative. So it's going to change the signs of everything. The 2x to the third is going to cancel out. You're going to have a negative 9x squared minus x squared is going to give you a negative 10x squared. And then you're going to bring down the next piece, that plus 7x. You're only focused on that negative 10x squared and that 2x. What are you going to multiply 2x by to get a negative 10x squared? So you need to multiply by a minus 5x. And you have to distribute it to the entire 2x plus 1. So you end up with a negative 10x squared minus 5x. Now you need to change the signs. So you're changing the signs here. That 10x squared is going to cancel out, and you're going to have 7x plus 5x is going to give you 12x. And then lastly, you bring down the plus 6x, or plus 6, excuse me, and you're focused on that 12x and that 2x. What are you multiplying 2x by to get 12x? You're multiplying by 6. You do the distributive property. You change the signs and you get 0 as your remainder. So your solution here will be x squared minus 5x plus 6. Pause and try. So again, you're setting this up as long division. I'm focused on that 3x squared, and that x, I need to multiply by 3x to get that 3x squared, and I get 3x squared plus 9x. Don't forget to change the signs. You have to change the signs for subtraction. And then you're going to end up with a negative 13x, bringing down the next piece, that minus 7. You want to get rid of that negative 13x, so you have to multiply by a negative 13 to that x plus 3, and you get a negative 13 minus 39. Now you have to change the signs, and you end up with a remainder. And when you get a remainder, and in this case a remainder is 32, how you write your remainder is you write your solution, which is that 3x minus 2, and because my remainder is positive, it's going to be a plus 32 over your divisor, which is that x plus 3. So this is how a remainder would be written. So now I want to show you when we have a case where we start off with an x cubed and then no x squared is in the problem. When you're missing a term, you have to put a place marker for the term that's missing. If you're missing a term, if you start with a cube, you need to have a squared term, you need to have an x term, and you need your constant term. So when you're missing a term, if one of those terms are missing, you need to put a place marker in. And that place marker will be a 0 for the coefficient, because it means I have 0 x squares. But I have to have an x squared in order to do division. So you need every place in order to do long division. So when a piece is missing, you always want to check, if you have a cube, that you have a square, that you have an x, and that you have a constant. If you're missing a place marker or place, you have to put that place marker in with the coefficient of 0. And then you'll do long division. So again, I'm going to start off by doing my division. I multiply by x squared. I get my 2x to the third minus 2x. Don't forget to change the signs. And then that 2x to the third is going to cancel. And then you have 0 plus 2. So you end up with 2x squared. Bringing down the next piece, which is that plus 4x. I'm going to multiply by x to get that 2x squared. I'm doing that distributive property. Don't forget to do the distributive property. Change the signs, and then you're going to add down, and you're going to end up with 6x, bringing the next piece down, which is that minus 1. And I'm multiplying by 3 to get that 6x. So I get 6x minus 6. Don't forget to change the signs. When you add down, you get a remainder of 5. And again, the way you write your remainder is, because it's positive, it's a plus 5 over 2x minus 2. So don't forget to write the remainder when there's a remainder in your solution. Pause and try. So in this one, you notice that the x variable place mark is missing. So you have to put the place marker with the x, so 0x. And then you'll do your long division. I want to get rid of the x to the 2x to the third, so I have to multiply by x squared. Multiply all the way through, and you'll get 2x to the third minus 3x squared. Don't forget to change the signs. It's subtraction, so you have to change the signs. The first piece is going to cancel out. You're left with 12x squared, and you're bringing down the plus 0x. And then I'm multiplying by 6x to get that 12x squared. I'm multiplying it all the way through. I get 12x squared minus 18x, and then I'm going to change the signs. The first piece will cancel. I get a positive 18x, and I bring down the next piece, which is 27, and I'm multiplying by 9 to get that 18x. I distribute it all the way through. And don't forget to change the signs here. I changed the signs, and I'm left with the remainder of 54. So be very careful. Don't forget to change the signs or distribute that negative. And then you get your solution is x squared plus 6x plus 9 plus 54 all over 2x minus 3. So this next thing that we're going to do is called synthetic division. Synthetic division is a shortcut for long division. As long as your divisor is x minus or x plus a number, meaning the coefficient of your divisor for x has to be 1. If the coefficient in front of x is not 1, you cannot use synthetic division. So now how synthetic division works is you write a half box, and then what you're going to do is you're going to take what the divisor is, that x plus 3, and you're going to give it the opposite. So it's plus 3, you want to put minus 3 on the outside of the box. So whatever your divisor is, you're always using the opposite of what it is. So it's the opposite of x plus 3 would be minus 3. So you put the minus 3 on the outside. Then you're going to list all the coefficients and the constant on the top row. If a term is missing, put a 0. That would be the coefficient for the missing term. So again, the next step is to take all the coefficients of what your polynomial that you're dividing into and put it in the first row. So the coefficient of x to the third is 1. The coefficient of x squared is a positive 6. The coefficient of x is a positive 8. And your constant is a minus 2 or a negative 2. Now we're going to start the synthetic division part. And how it works is you take the first number and drop it underneath the box. take the first number and drop it underneath. And now you're going to take your divisor, multiply it to that number, and put it in the next column. So a negative 3 times 1 will give you a negative 3. And then you're going to add down. So you have 6 minus 3 will give you 3. And we're going to repeat this. We're going to take that negative 3, we're going to multiply it to the 3, and we're going to put it into the next column. So negative 3 times 3 is going to give you a negative 9, and then you're going to add down. So you get 8 minus 9 is a negative 1. And we're going to continue until we have no more numbers. So I do a negative 3 times a negative 1 is going to give me a positive 3, and then I'm going to add down and I'm going to get a positive 1. Negative 2 plus 3 is positive 1. Now this last number is the remainder. So if it's 0, there's no remainder. But in this case, we have a remainder of 1. So now what you do with these numbers is you're going to put the variables back in, but the x is going to be 1 less power because we just did division. So we divided into an x to the cube. So when I write my answer, I'm going to start with an x squared and then an x and then down to the constant. So I'm putting the variable back in by reducing it from one exponent. So it was x cubed that I divided into. So when I start my solution, I'm starting with x squared and x and then to the constant and then my remainder. So the solution here is going to be the x squared plus 3x minus 1 and then plus my remainder 1 over the x plus 3. So you have to write your remainder over your divisor. And remember, when you have a coefficient of 1, you don't write the 1, and that's why it's just an x squared here. Pause and try. So the first thing I'm doing is setting it up. I'm writing my box. It's going to be the opposite, negative 1. It's going to be a positive 1. I'm going to take all my coefficients and write it in the first row. So I get 4, negative 3, 6, and 5. Then I'm going to drop down the first number. So 4 comes down. And I'm going to take 1 and I'm going to multiply it to 4 and I'm going to get 4 and I'm going to put it into the next column. Now I'm going to add down and I get negative 3 plus 4 is 1. I'm going to multiply 1 to 1 and I'm going to get 1. I add down, I get 7. And then I'm going to multiply 1 to 7 and I'm going to get 7. I add down and I get 12. And remember, 12 is the remainder. So now you're going to add the variables back in by reducing by 1 exponent. So it's x cubed, so I have to reduce it. It's going to be x squared plus the x plus the 7, and my remainder is going to be 12. So we end up getting a solution here of 4x squared plus x plus 7 plus 12 over x minus 1. Similar to the long division, if we're missing a term, you need to put that place marker. A missing term, you need a place marker. This does not have an x squared in it. You always want to double check that. We have x cubed, we don't have an x squared, we have an x, and we have a constant. So where the x squared should be, I would put a place marker of 0. So again, I'm putting in, the first thing I'm doing is whatever I'm dividing by is going to be the opposite. So it's a minus 1, so it's going to be positive 1 on the outside. I'm putting all the coefficients in. It's 1. My place marker 0 for the x squared. The negative 4 and the 1. And I'm doing my synthetic division. I drop the first number down. I multiply 1 to 1. I get 1. I add down. I do 1 times 1 is 1. and I add down. It's a negative 4 plus 1 is going to give me a negative 3. And then 1 times a negative 3 is going to give me a negative 3. I add down and I get a negative 2. And this would be my remainder. So you're going to add the variables back in, reducing it by one exponent. So I end up getting x squared plus x minus 3 minus, because it's a negative 2 as my remainder, minus 2 over x minus 1. Pause and try. So again, what's missing here is the x squared. I'm going to put a 0 in. Again, don't forget to do the opposite of the divisor. It's a negative 4. It's going to be a positive 4. Put all my coefficients in. 1, my place marker, 0, negative 6, negative 7. Bring the first number down. 4 times 1 is 4. Put it in the next column. Add down. 4 times 4 is 6. Put it in the next column. Add down. You get 10. 4 times 10 is 40. Add down. You get a remainder of 33. And then add your variables back in, reducing it by one exponent. So we get x squared plus 4x plus 10 plus 33 over my x minus 4. So before we start dividing polynomials, it is important to check the following conditions before dividing. The first condition is the polynomial must be in standard form with the exponents in descending order. And what that means is you need to have the term with the highest exponent in the first position, and then it goes in descending order all the way down to the constant. Next, you want to check if there's any missing terms. And a missing term is if you have an x to the third, then that means that you need to have an x squared, you need to have an x, and you need to have a constant. If you don't have all the descending terms from the highest exponent, you will need to put place markers in with a coefficient of 0. You can either leave a gap, or you could put the place marker. If there's an x squared missing, you would put 0x squared. And we're going to see examples as we go through this lesson.